This is day 14 of Advent of Code 2023, and this challenge is called Parabolic Reflector Dish. You reach the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rock deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of four directions. The rounded rocks, O's, will roll when the platform is tilted, while the cube-shaped rocks, hash, will stay in place. You note the positions of all the empty spaces, dot, and rocks, the puzzle input, for example. So start by tilting the lever so all of the rocks will slide north as far as they go. So they start piling up as you go up. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by a single rounded rock O is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load, so the amount of load caused by each rock in each row is as follows. Okay, so when you add all these rocks up, you end up with 136. So tilt the platform so that the round rocks all roll north. Afterward, what is the total load of the north support beams? Okay, so we'll grab the input. Actually, that's not the input, this is the input, or the test input. Okay, so we'll go copy the test input here. We will put it in here, and let's get started. So I assume part 2, we're probably going to have to do multiple directions, and I want to set it up, so I think I know how to do it. So let's say we're tilting it north, so tilting upwards. We start at this row, and we keep record of which spaces are open. So for this column, we can't record. This column, the first index is open, all of these are open. So then when we get to this row, okay, that's already there, it can't move, that's empty. We get to here, it's like, okay, we need to push it forward. What number do we have recorded? We have this number recorded, so we just move this one to here, and then this becomes the new opening number. Or in the case of this column right here, we go through index 0, index 0, index 0, and on index 3, where this is a circle, this moves to index 0, and then we go upwards again from there. So we've got it there. Is this one available? Yes. Now this is the most open one. But for ones where there's a rock, you go, say 0, okay, we've got a ball, we've got a rock, this then moves to 0, then it becomes 1, this is empty. Okay, we've now come across a rock, so this can't be it, the one above it will be the next open one, and then you go like that. So that's my idea for how it would work. So let's do depth tilt, and I want to be able to pass it a parameter which decides which direction we're going. Okay, I guess the question I have is, is this a cube? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one looks like a cube, but what about the rest of these inputs? Well, let's just copy this and put it in. So we've got 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Actually, I can just look at the bottom of VS Code. Okay, yes, it's a cube. That will make the solution easier to do. Basically, this is going to be direction, and for part 1, so this will be tilt, and then we pass it. Okay, so the first index is the Y, so it's for tilting north and south. So this will be 1, 0, and then we need to do for I in range input. This is why I wanted to see if it was a cube, because then we can just have a singular for I in range input, and the 10 rows which are here, that number matches up with the columns, so then this is the correct number no matter what. Although I need to change the range, because if we're going from bottom to top, it'll start at the very end, and this range would start at 0 going up. Actually, we can store this as a variable, and we can do, what would we call this? Let's do grid range equals range input if -1 not in direction, else range length of input -1. This will go to -1 because it's exclusive, and then this will be -1. Now we do for I in grid range. And we also want to keep track of free space, and we'll do that as a dictionary. Yep. So for I in grid range, and for this will be cell equals input direction 0 times I direction 1 times I. Is that correct? Let's see what this outputs. Okay, so that doesn't work. Range list object cannot be interpreted as integer. Alright, I forgot the length of input here. Okay, so that was the first column. Okay, so the idea of having it just work no matter what based on the direction doesn't exactly work, because we need to go first column, then iterate through everything. Actually, okay, maybe we'll do column equals direction 1 equals 0, and then row is that. So this right here successfully goes down the column. So what we'll do is index 1, index 2, and we'll do grid section equals, actually what we'll do is column equals index 1 if column else 0. Now we'll do the same thing for a row, and then we'll do the exact same thing in here. Then we just need to do column and then row, I think. So let's print cell, then we'll exit just to see if it works. So that seems to have worked. Then let's do 0, -1. And that should be this way. Sweet, that worked. So we can now iterate through everything as expected. So what we'll do now is if cell equals dot, we'll do free space, key equals row if row else column. So key equals, we will do free space dot get key none. Actually we'll do current free equals this. Then we'll do, I think this is column if current free is none, else current free. Then we'll do elif cell equals hash. Actually, we may as well just put that here because we're using it quite a bit. And we'll also put that there. So if cell is hash, then free space key equals none. And then we do else if it's circle. We will do if current free is not none. We'll then do input column row equals cell. No, not input. Okay, this is another one where it's need to figure out. Actually, even better. Row column. I'll just do that. Okay, where did this come from? Why is it column? Okay, actually the value will be row column. So input, then we'll do free space loc equals free space key. Then it'll be 0, 1 equals cell. And then it would be input row column equals dot. So let's try that once. Free space print. Actually, I'll just do that once. So exit. So it says 5 is none. Oh, that's right, I've done it. Okay, I need to change it back to this. Let's run that again. So 1 skipped. 8 or 9 was skipped. Oh, it's none. Okay, wait, no, it's this way. 0, 1, 2, 4, 6, 7. Okay, that is working. Cool. Although I think I need to change some of this. So we'll do grid equals input.copy. And then we'll do grid direction. Pass grid into here. Then wherever we've done input, change that to grid. Now does that work? Okay, it still works. So now let's see print grid. What does it look like now? Okay, I didn't think of that. For row in grid, print row. Okay, so nothing has changed. I guess we should print row column. Is that working at all? Okay, row isn't changing. Okay, these need to be flipped around, I think. So this is, if it's column, it's in 0, else this. Or maybe I have it backwards. Okay, let's get rid of some of these prints. Yeah, so currently row doesn't change at all. Or is it meant to be this? These are swapped around? So column is changing in here. Oh, okay, shouldn't be 0, should be else this. String does not support. What's going on with that? String does not support item assignment. Grid, print this, and we'll print this. Oh, I haven't actually split it up into a grid. I've just done the lines. Ooh, import.append for C in line. Ugh, there we go. Okay, but what is printing? That was getting printed. And get rid of these. I think that's properly working now. Let's say for line in grid print line. Okay, that's not worked as expected. It nearly did. Okay, get rid of this print. That is saying there's 2, 4, 6, 8, 10 circles. 2, 4, 6. What? How's this? Why is it skipping a bunch? I mean, it literally starts on circle. Okay, let's try print column row. Okay, column row, and then cell. If current free. Okay, that's why. Or is it? Okay, we're gonna chuck this below here now. And then we'll do key current free. Okay, this should be the other way around. Column. Now we'll uncomment this and run it. I feel like it just added a bunch. Okay, we're using the wrong values. Some are a heap of 1, 2. Okay, now let's do from column row to free space. Look, from 39 to 90. Okay, we've got it backwards. Yeah, right there should be this way. Still adding stuff from nowhere. Okay, we've got to change it here, so we need to change free space now equals none. Ooh, okay, we nearly got it. That's 2, 1, 2. Ah, okay, did it wrong way around again. Column, wait, is that right? Column row? That's nearly correct. Maybe print grid column before and after? We know that doesn't make sense. I guess we need to find, so 0, 3, what happened to you? I guess this is actually 3, 0 to 2, 0. That is correct. Now what happens to you? 5, 0 to 4, 0. Okay. No, this is meant to equal the current column row. I was thinking the next iteration is going to go to here and update, but it's not, obviously. So I need to do this. Okay, so we've got that one right. But now what's... So that goes down, but then something messes up here. So let's find... Actually, what was this one correct? Okay, no, it all messes up. So let's find 4, 1. Okay, apparently it's none. So let's say if column equals 1 and row equals 2, print cell. Well, I don't need to do that. So 4, 1. So this starts off 4, 1. 1, 4, 1. Wait, no, I'm looking at this one. Okay, so I put the wrong number again. It's meant to be, well, I need to change these number. New col equals free space like 0 if row else this plus 1. Then same thing for new row, except it's 1 column 1 new col new row. Now let's try that. There we go. That looks much better. If we missed anything, need to compare that to this. Okay, this is looking right now. Okay, so when we do that, we now need to calculate total score equals 0. Oh, actually, we'll just put that at the bottom. Total score equals 0. And now we need to do, actually, no. So for num in grid range, this will be, it's going to be these numbers again, I think. but we switch around the condition. Then we do if grid column row equals circle, total score plus equals length grid minus index 1. Then we return total score. Okay, so what do you do? None. Okay, that's because I need to now return tilt 136. Awesome. Okay, so let's get rid of a bunch of these print statements. 136. Now let's grab this, put it into here, and run it. 112046. And that is part 1 now completed, so on to part 2. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labelled Spin Cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After 1 cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. Here's what happens in the example above after each of the first few cycles. So, after 1 cycle? Oh right, that's a whole cycle is going north, west, southeast. Okay. This process should work if you leave it running long enough, but you're still worried about the north support beams. To make sure they'll survive for a while, you need to calculate the total load on the north support beams after that many cycles. Oh, okay. In the above example, after this many cycles, the total load on the north support beam is 64. Okay. Damn. So we're going to have to change a few things, and we're going to probably need to use caching for it. So this will be grid input copy, but just to double check it's not actually getting changed. Oh, okay, it's getting changed. Let's do grid equals list for line in input grid dot append line dot copy. Now let's try like that. New lines in this the whole time. Didn't even realize. Dot f strip. Actually, what isn't it? F strip? R strip. Okay, there we go. So we've now got our unique grids. But now for this, for I in range this number, then for direction in 1 0, then we need to start over here, so that would be 0 -1, and then it will be -1 0, then it will be 1 0. Okay, so we're going to need to create more functions for this. No, what am I talking about? Score equals 0, score plus equals tilt grid direction, and that can just be changed to underscore because it's not used. Then it would be return score. Let's do if this, because we need to, if that equals 3, exit for row in grid print row. What does that do? Okay, line 35. So it's breaking here. Oh, why would that be breaking? We're going to comment out part 1 just so we don't get constant outputs. Line 35. Print free space lock. Oh, interesting. How did it become 10? Oh, actually, so it shouldn't actually be +1 here. It should be plus direction 0. And this would be plus direction 1. Although now that I've done that, let's bring back part 1. 136, so that still works. Oh, okay. Compare that to this, and it's completely different. Did I get this backwards? Yes, I did. I thought it was east and west. Now let's try that again. Okay, it's not working at all. So we're instead gonna do the same thing in here. Okay, so just verify that first iteration worked. Wait, it doesn't seem to be changing at all. So that stays the same. Oh no, that did change and that's correct. And it goes down. Then this one didn't work. These should have all gone over to here. Why didn't that work? Or did I forget to... No, that number's... Okay, so may as well get this out of the way now. We're probably going to be from func tools import cache. We will be at cache this, and we will need to change these to tuples, and then change these to tuples. Does that work with the cache now? Nope. How do you add to a tuple? Apparently you can't. So what we'll do, grid tuple, this will be for line and input, tuple copy. And do the same thing here. Did part 1 print correctly? Oh, tuple does not accept item assignment. Okay, no, I got it. So let's copy this. Let's change it back to how it was. So keep like that. We just need to do this. No, that doesn't work. Actually it does. So it's going to be dumb. So we're going to be converting it to a tuple, then we're going to be converting it back within it. So we can get rid of these. We've got grid equals row for row in grid list. What do you mean grid's not defined? Oh, down here. I must have kept something. Oh, okay. Okay, I need to keep record of it in here. Return total score on grid. Okay, let's undo a bunch of stuff. No, we will copy this. Return grid. Score grid equals this. Return score. Grid equals for line in input line dot copy. This will be for row in grid. This will just be row. This will be new score grid equals that. Then score plus equals new score. Okay, so that took a while, but okay, we've got this now. I don't remember why I was doing that because I was meant to be fixing this. Alright, I said I'll get out of the way doing that part. So okay, so we need to fix this, but I don't know why it's looking like that. Let's just print direction. Wait, why did I do -1 twice? Okay, I did it the wrong way round. This is meant to be 0, -1. Now let's try again. Now how does that compare? Okay, let's go back to the top of this. So after one cycle got that. Oh, 1, 2, 3, 4. Okay, that is looking correct now. Yep, those are all good. Then we go 1, 2, 3, 4. So that's this one. 1, 2, 3. Yep, that's all correct. Then 3 cycles. Oh, that is also correct. Okay, so now let's try this again, but we remove all of this, and let's see if we can have it run this many times and it still works. Okay, well it's getting stuck somewhere. So just cancel that. What was it? So we still got this in here. We're actually looking at this. This is part of what we need to change. So we'll take all this out. We will put that here. So this will be grid. This will just be grid range, length range, grid. Because we know how this works, we don't need any of this. Then it'll just be the same thing here. And it will be index 1, index 2, return total score. And I'm just going to comment out part 2 just to see if that works, which it doesn't. This cannot be interpreted as an integer. What am I returning? Oh, that should be fine, shouldn't it? Print grid? What's grid? If it's an integer. What? Oh, okay, I've got it the wrong way around. Not sure how I did that. Okay, cool, 136, still getting that. And then it'll be the same thing, but now over here. So unrange, got the grid. Don't need this anymore. It will be this. Okay, let's run it. Alright, I need to uncomment part 2. Now run it. Maybe, let's print this for now. And then we'll also get rid of this part, because we don't need to check direction anymore. Okay, I thought cache would have solved that. Can I maybe print, can I do grid to string? Or just convert it to a string? You know what, I've got an idea for my own caching. We'll just keep it set like that. We will do prev grid equals string grid. Then we'll do, wait, no, this is meant to be up here. Then we will do if prev grid equals string of grid. We will break. I wanna see if that does anything. Okay, so that's not gonna work. Maybe to help with caching, we can put this in it or something. Let's do def tilt section at cache, and this will be section. Okay, something I've realized with this, it's not going to work. It's going to assume it's like literally the previous time it was the exact same, but it's not going to be like that. It's going to be more like a pattern. So it's like, let's say it reaches a point where if it does it 10 more times, then it's going to be the same. So what we'll do, dict prev grids equals dict, and prev grid, this will be prev grid this equals underscore or prev grids, and we'll do if string grid in prev grids. Then what we'll do, this will be index prev index equals prev grids string grid. We then need to do, what should we do, difference equals index minus prev index. Then we'll do repeated index equals index, and this would be while repeated index plus difference is less than this, repeated plus equals difference less than equal to. Then we'll do if repeated index equals this, then we break, otherwise it will be find index equals this minus this plus prev index. So we've now got this. We'll then need to do for key val in prev grids dot items if val equals find index. We could if it equals, I'm pretty sure you can use, it's eval function, so like grid equals eval key. Then we break from that. Let's do found equals false, found equals true. Oh, actually no, we don't need to do that. So does this, that breaks from that breaks from this. I'd like to think this works. Oh, okay, you actually got a number. Is that correct though? 64. No, that's not correct. We've got the wrong number here. It should be, or repeated, less than, not less than or equal to. If repeated index equals this minus 1, and it should be minus 1 for these. Now try again. Why is it returning 69? Okay, let's print some numbers out. Print index, and we'll print this. We'll then print find index. And then when we hit, let's just print key. Curious. Actually, no, we'll print grid. Why did 9 and 3? What? Okay, let's print grid. Maybe we should print index, see what's going on there. And we'll just do if index equals 3, print grid. Okay, those do look the exact same, but why are we getting 69? Okay, get rid of all those prints. And let's try already. So maybe for this, let's just print here, because maybe it's getting that number, repeated index. Okay, so if we remove the -1, it shouldn't go into there, right? Okay, maybe I need to take a look at what's in prev grids. Okay, what have I done wrong? Maybe let's just print this, index 1. Actually, we'll do this. And we'll do I enumerate grid, and we will print length of grid minus I. Yeah, so we've got 9, 7, 6, 6, 6, 5, 5, 4, 4, 3, 3, 3, 2, 2, 1. Okay, so that is looking to be correct. Let's print total score. Maybe there's something missing. Nope, that looks correct. I don't know what's wrong with it. I guess to make sure that we're getting the right number, let's just create a function. Def calculate score grid, and we'll do this. Return calculate score grid, and that'll basically just be the same thing here. So rerun that. Okay, so we are definitely doing something wrong. Alright, let's just try removing this and see what happens. And what if we remove the -1? What happens then? Wait, did it return the exact same thing? No, it didn't. So that is different. Interesting. Now, what if we try -2 remove? Because it could be that I've just got this maths wrong and I don't know, kind of just trying anything at the moment. How is everything returning that? Because I'm curious, let's do for g in prevgrids.keys print calculate score eval g. So what does that give us? Okay, so we found the one which is 64. 0, 1, 2, 3, 4, 5, 6. Although is it meant to be that one? Okay, let's index, prev index, repeated index. What do those numbers give us? Okay, see how this was happening. The reason why we're getting the number. So it's doing this minus this, which is all the 9s minus repeated index, which then makes it 0, then plus index, which makes it 3. Out of curiosity, I'm gonna do it on the real input and see what it does. Okay, well we've got a number, 104639. I mean it's not gonna work, but I just want to test it. Yep, as expected, didn't work. But it was nice to see that it ran very quickly. What number's getting printed out? Oh right, this at the very end. Then also printed the grid, which you don't need. So we'll change it back to here. Just run it again. Look at this. The thing I'm trying to figure out at the moment. So if we actually let's put those print statements back. So the thing I'm trying to figure out. So 0, 1, 2, 3, 4, 5, 6. Index 6 has it, but then we found it on 9 and 3, and the difference is 6 for that. So 9, 3, starting at 3, adding 6 goes to there. Let's grab calculator out. 1, 2, 3, 1, 2, 3, 1, 2, 3, divided by 6. Okay, so that doesn't go into it. 1, 2, 3, 1, 2, 3, 1, 2, 3, minus 3, divided by 6. 1, 2, 3, 1, 2, 3, 1, 2, 3, divided by 6. So that goes into it. Oh, but is that right? Still trying to figure that out. So I'm trying to think if it's like, so because it's from numbers 3 to 9, should it be like some offset in there? What if we move the plus previous number? What if that's the issue? Okay, no, that's not it. Maybe we want to do this. Don't know if that's what we want, but I'm just going to put it in anyway. So I think the math has confused me. So we do get that, but it's a matter of whether that actually works with the real input. So let's try that. So run that. 104620. Was that the numbers being, it just confuses me. You know, it starts at index 3, it goes to, the loop is up to index 9, but then wanting index 6 is like, I don't know if I'm trying to just force a pattern, because there is a pattern 369, don't know if I'm trying to force that in to make it work or not, but let's see if that worked. No, it's too high. Yeah, so, no, I just realised I've been doing this so long and it's dark my screen. Let me go turn a light on. Okay, that is better. Maybe something I can try, if grid, just to see, if grid and prevgrid, print index prev index, and then we just continue and change that back to test one. So as we can see, okay, so that definitely is the pattern. Okay, so what does this tell us though? So we know it's 6 apart. I don't know, is it possible I'm missing something with this? I mean, I don't think so. So one cycle is when it's finished on the east one, so it's gone north, west, southeast. Okay, so I need to get rid of this now. Actually, maybe this should be just plus difference. Oh, actually, that doesn't make sense, but I mean, kind of just trying everything. Was that what I did last time? I can't remember. 102984, is that it? Too low. Interesting. Although, why is it 64? Actually, I just realized I don't need to do this. That big of a number. Do I just need to do this modulus difference or something? Modulus difference plus prev index. Actually, this should be the find index, I think. Let's run that. 104618. Nope, still not the right answer. Took a break. Now I'm back, and I think I might have an idea for this. So we'll go through it one at a time. So this is the very end. There are 1 billion iterations of this. So when trying to figure out which one we need to do minus prev index. So this makes it so it's now going to be repeating forever within that loop. And to find out the one that we want, it will need to be difference. So we got the modulus part right. So we've got the current number, and then we're going to modulus difference to find out whereabouts in the loop it is. But then we need to do the plus prev index to get the actual index of it. So, okay, I need to go back and get the first one. Let's grab that, put that here, run it, and hopefully it gives the correct number. Gave 69. But back to this, are we? So something I just realized. This for loop with the index, so we use index, we add the current one into previous grids and set the index, and then we run through it, and then if this grid isn't here, we're still using this index, which is for the previous one. So it's actually the next number that it should be. Okay, what is this error now? I've been making so many changes I don't remember. Oh, okay, whatever, get rid of this. Okay, what even are these numbers I'm getting? Alright, we're not breaking from it. 64. And now if we run on this one, 104619. Okay, finally we got it. Man, I spent so many hours on this. And it's always just little things like that which I overlooked. Like I knew there was something up with that index, but I couldn't see what until now. Well, anyway, that is day 14 of Advent of Code finally completed. If you like this video, make sure to like and subscribe so you can watch me suffer through these challenges.